Hi, this is Wendy Lightheart, and in this video we're going to be taking a look at complex rational expressions. Complex rational expressions are rational expressions that contain one or more fractions in the numerator and or the denominator. So here's an example of a complex rational expression, because notice that it has a fraction in the numerator. Also, it has a fraction in the denominator. We just need one of those fractions to be there for it to be considered complex. And what we want to do is to be able to simplify these complex rational expressions to more simple rational expressions. And in this video, we will be learning two different methods for simplifying complex rational expressions. The first method is by using the least common denominator. So here are the steps of how to simplify a complex rational expression using the least common denominator. So the first step is to find the least common denominator, and the least common denominator that we're referring to is the least common denominator of all the fractions in both the numerator and the denominator together. The second step is to multiply both the numerator and the denominator of the complex rational expression by the least common denominator that you found in the first step. Remember that with a fraction, if you multiply both the numerator and the denominator by the same thing, then you'll end up with an expression that's equivalent to the original. And that's what we want. And when we perform this multiplication, all of the fractions in both the numerator and the denominator should be cleared. And so this will give you a rational expression that's no longer complex. And of course, sometimes it can be simplified even further. So we may have to look at the numerator and denominator and see if they will factor and then cancel common factors to completely simplify our rational expression. Okay, let's get started on an example. So here's the example that we looked at earlier. This is a complex rational expression because it has a fraction in the numerator. It also has a fraction in the denominator. So what we want to do first, remember, is to find the least common denominator of those two fractions. So you're thinking to yourself, what is the least common denominator of the fraction 1 over x and the fraction 1 over x squared? The answer is x squared. So that is the least common denominator that we're going to use to simplify this complex rational expression. And what we do with it is we're going to multiply both the numerator and the denominator by the least common denominator of x squared. Now notice that in the numerator we have addition. So we have two terms we're going to have to multiply this x squared by. So this is why I put the parentheses around there. And I'm going to have to distribute the x squared through. Same thing for the denominator because of that subtraction sign. So we're going to have to distribute that x squared and multiply it times the 3 and then multiply it times the 1 over x. So using that distributive law, we'll have x squared times 3 plus x squared times 1 over x. And then we'll do the same in the denominator. We're going to distribute that x squared, multiply it times the 1 over x squared, and then also times the negative 9. So we'll have x squared times 1 over x squared minus x squared times 9. Now when we simplify this, we should see all the fractions in the numerator and the denominator go away. So when we multiply x squared times 3, we get 3x squared. And then we multiply x squared times 1 over x. This gives you x squared over x, which reduces to just x. So that fraction, notice, was cleared. There's no longer any fraction in the numerator. Now we're going to do the same thing in the denominator, and we should get the same kind of result. Notice when you multiply x squared times 1 over x squared, you get x squared over x squared, which is just 1. So we'll have 1 minus 9x squared in our denominator. Notice there's no fraction in the denominator anymore. So now this is no longer a complex rational expression. So it is simplified somewhat, but we need to make sure we simplify it completely. So our next job is to see if this will simplify more. So we'll do that on the next slide. So remember, if you want to simplify a rational expression, you need to factor both the numerator and the denominator completely to see if you can cancel any common factors. So in the numerator, if you do your first step of factoring, which is to look for a greatest common factor, notice that there is a common factor of x that we can factor out. So that will give us x times 3x plus 1. And then in the denominator, we have a difference of squares. So that'll factor into 1 plus 3x and 1 minus 3x. Now we're going to look for common factors that we can cancel. And notice that 3x plus 1 is really the same as 1 plus 3x by the commutative law of addition. So we can cancel those factors out. But that's all we can cancel, so we're left with just an x on top. And then the 1 minus 3x factor, since it's no longer being multiplied by anything, we're going to drop the parentheses off of that, and that will be our denominator. And that's as simplified as that expression is going to get. So, remember what this expression looked like originally, this complex rational expression. We've now simplified it to something that looks much simpler. Okay, now let's look at another method for simplifying complex rational expressions. This other method is by dividing. So when you have a fraction, remember that the fraction bar really means division. So what we're going to do is actually turn that into a division problem. So the first step in this method is to perform all the addition and subtraction in order to obtain a single term in the numerator and a single term in the denominator. And being a complex rational expression to begin with, it's likely that you're going to have a fraction in the numerator and a fraction in the denominator. That won't always be the case, but most of the time. So when we perform that division that's denoted by the main fraction bar of your rational expression, remember that when you divide by a fraction or number, it's the same as multiplying by its reciprocal. So since the numerator is being divided by the denominator, we're going to rewrite that division as multiplying the numerator by the reciprocal of the denominator. And then we are going to simplify by factoring, because we might be able to cancel some common factors, and then we'll perform the multiplication and we'll be done. So we're going to look at that same example that we looked at earlier, but we're just going to use a different method. So remember, the first step for this method is to perform all the addition and subtraction in the numerator and the denominator so that we only have one term in the numerator and one term in the denominator. So if we look at the numerator first, in order to add 3 plus 1 over x, we're going to have to get common denominators. So since the denominator, the least common denominator obviously is going to need to be x, we would need to multiply the 3 by x over x so that it has a denominator of x, but it's equivalent to what it started with. And now we're ready to add those together. So when we add those two fractions together, we have x as our common denominator, and then we add the numerators together to get 3x plus 1. So notice this is a single term. It started out as two terms, but now it's a single fraction, so it's one term. Now we're going to do the same thing in the denominator. In order to perform that subtraction, we're going to have to rewrite 9 so it has a common denominator of x squared. So to do that, since it's a whole number, we just multiply both the top and the bottom by x squared. And now they have the same denominator, so we can perform the subtraction. So our denominator will be x squared, and our numerator of that subtraction result will be 1 minus 9x squared. Okay, so now we have a single term in the numerator of our original fraction and a single term in the denominator of our original rational expression. So now what we're going to do is we're going to rewrite this as multiplication, because when we're dividing the numerator by the denominator, that's equivalent to multiplying the numerator by the reciprocal of the denominator. So that's going to look like this. Here's the numerator, 3x plus 1 over x, and we're going to multiply that by the reciprocal of the denominator. So we're going to flip that denominator over. So now, to do multiplication of fractions, remember that you want to factor everything, because you might be able to cancel common factors before you actually perform the multiplication, so that you'll have a simplified answer. So we can't really factor much here. The 1 minus 9x squared is a difference of squares, so we'll go ahead and factor that. And notice that the 3x plus 1 and the 1 plus 3x will cancel each other out. And then if you look at the x and the x squared, those will cancel, leaving behind an x. So x squared over x equals x. So we end up with this x in the numerator. So all that's left in the top is the x, and in the denominator we have the 1 minus 3x, which again is not being multiplied by anything else any longer, so we'll drop the parentheses around that. And notice that this is the same answer we obtained using the other method, using the LCD method. So you can really use this method or the LCD method to simplify any complex rational expression. And there's some expressions that it's easier to use the LCD method. There's some expressions it's easier to use the division method. And so it's really good for you to learn both methods so that you can use whichever is most efficient for that particular problem that you're working on. Alright, well that's it for today. Thanks. Bye-bye.